Today's session is openBIM Awards Program finalists for the category of technology. Our finalists in this category are BIM and Scan, the BIM and Scan openBIM cloud platform, AutoCorr and AutoGen, validation and reconstruction tools presented by Dr. Sean O'Keefe. Then we'll have from BEXEL Consulting, BEXEL Manager, Smart Integrated openBIM Approach from Velko Yannick. And then we will have future site implementation of BIM-based building permit process in Estonia from Britt Kluster. This session is scheduled to last 1 hour and 30 minutes with a short Q&A for the jury at the end. Now I'd like to hand over to Dr. Sean O'Keefe, who will be our first presenter.
Thank you for the wonderful introduction, and sorry I'm not there with you guys this time. And let's get started. So, and thanks for having us here again, by the way. So today we're going to discuss our BIM and Scan solutions. And the first one we'll discuss is AutoGen, which speeds up scan to BIM processing time by bringing value of creating automatic coordination models from point clouds. And the models are automatically semantically defined and so forth. And in many cases, you can use them straight away for energy analysis and so forth, which we can discuss later. And then the second is AutoCorr, which validates model and site issues, and it actually the algorithm comes from validating the AutoGen models actually, and we can discuss that more. Basically, BIM and Scan has a new platform now actually in the cloud, which we have different computations that allow us to do things with point clouds and so forth. And so for the openBIM achievements, as I was mentioning, we have automatic low level of detail coordination model view definitions created from the point clouds automatically. And we have several projects where this was worked on, and also integrating with major vendor tools as well. That's actually a social media client there, and that model actually was created and saved 2 weeks on an 8-week project, and maybe I can discuss more of that later. And it has to do with the poured concrete columns there. And then AutoCorr, we're taking coordination model view definitions first and foremost, because that's still unfortunately the most widely supported geometric model view definition, but also it lends itself to being properly used within the workflows because these are coordination related activities. So we take these coordination models and ordered E57 scans with scan positions, and then AutoCorr computes the difference between the two, and then several results are given, which we'll discuss after. And those are many thousands of issues there from an airport, actually. I think we mentioned it again later. So a little bit of background. So the initial major problem statement was found basically in around 2013, when I was asked to analyze a problem in a semiconductor facility. And basically humans are not very good at this exercise at all, of overlaying point clouds onto models and trying to find deviations, and then also further communicating what they think they found to people who can actually amend it and fix it in this world of so-called digital twins that people are wanting at the end of handover on projects. So the major problem statements are: construction always deviates from design. It's just a matter of where and have you accounted for it. Models from point clouds are poor in quality, and all model and site issues never get addressed, actually. So as I was mentioning, manually overlaying point clouds on top of models and trying to spot check is not the way to solve these problems. And in fact, when I first saw the problem, there was dozens of folks in a given area with a model and point clouds. It was actually this model here, and the point cloud was overlaid on the model, and no one can actually say how many issues they find a day, or exactly where, or have all the issues been fixed and by whom. So it's quite a huge problem, and this is very much common practice. Okay, so what we learned is spot checking traditional methods just doesn't work. Okay, so it's so here at BIM and Scan, we want to take these subjective problems that humans aren't good at and provide a efficient, objective, and testable solution based on science and open standards. So AutoGen, major use cases is scan to BIM development, space planning, retrofit, energy and structural analyses, and so forth. And most of this is around architectural models that are automatically generated from point clouds and the IFC spaces which are in them, which can also be leveraged for different use cases like energy analysis and columns and so forth that can be used for structural analyses. And then also AutoCorr, the major use cases, scan to BIM checking, site equipment install monitoring, construction monitoring, as-built BIM checking, and many other use cases still we have not found yet. So we have definitely over 400 users. I need to do another count, but it should be getting around 500. And we now are in 52 different countries. And it may seem like a relatively small amount of users, but if you think about each user representing a company where there's only one of these people and one license, and they're using this on a real project, it's a substantial win for us to know that we have approximately 400 projects around the world that have used the software applications. So the main objective with AutoGen is to speed up scan to BIM processes. This is actually a building in downtown Dublin where you can imagine having to navigate that point cloud, which is very subjective, and being able to use a tool that efficiently helps you speed up to get a proper semantic model in the end. So the best practice workflow is to do one floor at a time. We can compute and create more than one floor at a time. But if you look at traditional architecture and design processes and engineering drawing at its basics, its foundation is upon creating one floor at a time, just like we create a set of construction documents. So the idea and philosophy is the same way. We use one floor at a time and we build these up. And basically the models look like this when they come out. And when you have this overlaid with the point cloud, it's a more efficient tool, and we'll see that in a moment. And updating it is relatively quick. All IFC compliant design applications support IFC via the API. So there's not much work except just clicking on the IFC window object in this case and selecting the right object from the library. And then away you go, creating your drawing documentation and so forth. Here's an image showing how we use AutoCorr to check the automatically created models. And AutoCorr, one of its outputs, as you'll see, is BCF. And it shows not only can we tell you how the computation was created within what tolerance and what's the global unique ID and so forth, we could also give you the coordinates on how to fix the model. And the expectation of that on our roadmap in the future is to automatically fix these models with our AutoDiff application. It's been published, I think, even as far back as 2016, and you can look that up yourself. So the idea is to automatically create models and iteratively loop these algorithms over them until they fix themselves to a high level and degree of quality. And this is another image just showing where I was just selecting the door and actually building the model using both of the applications, AutoGen and AutoCorr, at the same time simultaneously. In this case, I was using ArchiCAD to amend the model. This is a good use case from 2016, long ago now that I look back on it. And as I mentioned earlier, saved 2 weeks on an 8-week project, so about a quarter of the time. And the reason being is we automatically generated all of these poured concrete columns that actually all settled different. The idea was we needed to have them all exact as per a contract. And then I actually used the AutoCorr algorithm to automatically check and validate and print a report saying that all the columns were in place. And basically for this 6-story building, we had 2 weeks allowable for these structural elements. So AutoCorr output files, we have the semantic point cloud, which what happens is the computation, it checks both the model and the point cloud within a user tolerance. Different contracts have different tolerances allowable for mechanical and electrical versus structural and architectural. And basically you can input the contracted tolerance and then it finds a correspondence. So AutoCorr means auto correspondence between the point cloud and the model. When the object is found, the point cloud then inherits the IFC semantic data. Therefore, the colors are representative of the IFC objects of which they now represent and belong to. So BCF messages are automatically created from an accountability point of view. We can now account for all objects. Earlier, I mentioned that humans are not good at this and everyone finds a different number of problems and so forth. This finds everything about every object, whether it was computed and found to be within tolerance or it wasn't found at all. And you'll see later a use case in Amsterdam Schiphol Airport where it's very valuable to know about objects, even if there was no correspondence between them and a point cloud. For instance, pipe work above ceiling tiles and things like this, or even within walls or components within other components. There will be BCF messages created for every object. And it's attached, of course, to its global unique ID. We can create the reports like this fairly quickly. A value for the report is on the very right-hand side, and we could do more statistics than this, but we don't want to overwhelm the users. We have the amount of points that are associated with the object and the scan position that saw the object. So retrospectively, people who are doing the laser scanning can use this as planning for scanning lessons learned, and actually there's PhD students using this type of information to create planning for scanning algorithms, and I participate in that as well. Those publications can be found. Also, we have heat maps, both absolute and relative. And on the bottom right-hand side, you see the relative heat map, which can be used for like ASTM standardized specification checking for floor flatness and these types of things. We use it for tank deviations, steel deflection, and all types of things. The most common one is the concrete and floor flatness. And then we have the absolute heat map for repositioning the IFC objects. So in a nutshell, if you get it in its best green location, that's where the object can be repositioned, and this is just a guide to help. Outcomes and projects, basically over time, there's many projects. The objective is almost always updating to the model to reflect the as-built state, and with geometry comes data. So as far as operations and maintenance data, one of the model view definitions that usually work hand in hand with our modeling processes is the Kobe model view definition, which I'm part of I am the technical requirements lead on the new IDS that's actually going to replace that one. That's a story for another time. So basically this data and its geometry is what's important. We've been very successful at on semiconductor facilities, water treatment facilities, pharmaceutical plants, so the pharmaceutical plant there is very important about the reactors and are they in the right position and these types of things. Airports, both Ireland and Schiphol Airport in the Netherlands, tunnels in Spain, Opera House in Hungary, validating that digital twin that was contracted to be made. Nuclear facilities, the theaters in Netherlands, I believe Stein might be there, who participated in that one. He might even be in the room with you there. So our new direction is open operations OSS site system. Basically, it has both a mobile application and a web application. This application itself is not up for this award. I might submit it next year, but it's just showing a direction where we're using all of these lessons learned from all the great folks that have supported us at buildingSMART. We've taken so many lessons learned from Matthias and Leon and Stein and all of these folks there with you. Basically, in a nutshell, this system is built first and foremost on business process models using IDM at a high level. And that first diagram there is showing the relationship while scheduling tasks between the web application and the mobile device. But the important part is, even at a more granular level, IDMs are made for every single data exchange within this system. We have an overall schema. In this case, for this example, it's a new model view definition that we created for telecommunications lifecycle information exchange. And basically, out of the overall schema, we have sub schemas for every single piece of data. And then we use those sub schemas to actually create the systems architecture. And there's not a piece of data or model or anything within the system allowable without being both verified and validated. You can look up those definitions according to ISO 9001. We don't really have the time to discuss that today. And we're in the process of creating the BCF Manager for this application. We're actually working on that right now at this moment. We have the ability to automatically create the images within the BCF, which I believe Matthias Natrop actually asked for that as a lessons learned years ago. In the new system, we can do that now. In our old business model, we were computing the files and the results and giving them to you on your computer where you can use them in whatever application you want, hence supporting open standards. But this application here is fully built on all open standards, 100%. And it will allow the users to do all these things that they've asked us to do over all these years, and have a viewer that's built on BIMWorks so it's BIMWorks viewer. You can look it up yourself. BIM-based by Ruben, and that's the direction we're going on primarily with the new application. One of the things we were asked is, do we have plugins for Revit and other applications? And we've started doing that, harnessing the power of the Revit API and our AutoCorr API, and integrating both AutoCorr directly in the applications, and also allowing other applications to integrate with our new OpenOps solution. And why people would want to do this is for many, many reasons. Most of the design applications are because these models need to be updated in the design applications, and that's one of the use cases. So in this case, the AutoCorr plugin for Revit allows you to select your point cloud, select your model. The computation is done in Azure Cloud, in ACI. It drops the files onto your computer, and then you can use them that way. And we're also working on the BCF Manager capabilities with the BCF API, and how we can do the same in Revit that we're currently doing in OpenOp by creating the automatic images and things like this. So participants and contacts, some of our main use cases and folks who wanted to support us in this endeavor. The first one would be ASRA, there for the buildings domain in Vienna, Austria. So this is an installation and handover validation with AutoCorr. So it's one of the primary typical use cases where architects are becoming responsible for handing over models that have been validated after construction and known to be accurate. So both geometrically and the data content within those models. And if you would like to know more about how Azra and her team used our applications, she is one of the main architects, if not the lead at SIDE. And for the waterways, top right, this was amazing use of AutoCorr. I never actually would have thought of this myself, but Tavi at Tulatech, I believe he's the CTO, they thought to use AutoCorr for checking the pipe works within the floor at the Port of Tallinn before they finalized and poured the concrete. And then they also would use AutoCorr for after the concrete cured. And it just amazed me when I saw this use case. So structural concrete validation with AutoCorr, but actually if you check those, the pipes in the image, it makes for a good image as well, I think. And VDC base, Lex and I worked on several projects in the Netherlands, and this one here I believe it's a bank. There's several of them, but they were predominantly infrastructure related. In this case, the terrain and road validation with AutoCorr and checking to make sure that the infrastructure was modeled according to the data that was captured about that infrastructure. And you can see in the image there where the heat map is being used to see the deviations in an overall manner. And of course, there's a lot more to it. And if you want to know more about it, feel free to contact Lex at VDC Base. And the last one I'll mention is airports use case, where Matthias Natrop and one of my colleagues, Dr. Connor Dorr, went out with the laser scanners in Schiphol Airport and used AutoCorr. And Matthias has such a great knowledge of BCF and so much experience on site as well. And when you start to find out that the traditional site walks that these folks have to make and how long it takes to actually solve just a single problem or find one deviation on the site, it really shows the value. And in this case, it was something so unexpected that when you're doing a site walk and you're going to address a problem, and now you've used a software that automatically checked and found some problems, and now you're not walking all the way across the airport to find just one problem. You're doing it in a systematic way using BCF and so forth. And all of a sudden you notice that there was so many objects now in the roof or in the walls that were never modeled. They were built. They're not on any documentation. And the software has now highlighted that these objects exist. So I hope I explained the use case properly. I wasn't there with Matthias and Connor, but my version, for me, that's the gist of it. If you want to understand more about it, you can contact Matthias. And Matthias actually led the way with AutoCorr on how do you merge all these different BCFs from these different applications and actually use BCF messages that used point clouds to find information and those BCFs were merged into other applications that don't support point clouds at all, but you're using point clouds to solve the problem in these applications. It's just amazing to see the use of open standards in this way. And it was just a pleasure to work on these projects with these highly skilled professionals who also support buildingSMART. And it's just great to be a part of this. And thanks for listening to the presentation. Feel free to contact me at any time, and I hope to see you all again one day. Thanks.
Thank you very much, Sean. I will just leave you, if you want to hang on, we'll do the question and answer for the jury at the end of the session.
Okay.
Great, thank you. Perfect, so now I'd like to introduce Velko Janiek from BEXEL Consulting. Let me just get the screen up for you.
Thank you for having me here. So it's really a great pleasure, finally after 3 years, to be here in person. Okay, so today I'm going to talk about integrated and holistic approach, and how the vision is how we can, up to the maximum level, utilize everything which already exists in IFC and generate a lot of data. And this is the focus: check the data, but also the key is to generate a lot of information and reuse them with the automation and so on. So about us, around $250 billion projects are managed currently, around 5,000 projects. Maybe this number is now a bit more, 65 countries. And we are proud to get a lot of recognition also by buildingSMART International. So this is the 4th time we have been the finalist in different categories. So it also shows about our holistic approach. And last time we competed, we have been the winner of Innovation Award. So here are some of our products. So, and I will try to show you how we combine this. So essentially, you have a good knowledge database and templates, and you will see how we use those templates in automation processes. So just to combine everything we already have in IFC with a lot of templates, checklists, and so on, which an example is IDS, or could be BSDD, and so on. But there are a number of others. We hope they are going to be also part of the standard. And then literally automatically you can generate reports like in a BEXEL viewer, a portfolio manager, or do a BEXEL docs and facility management solution incorporated. What is the key challenge of today's in construction management? The thing is that if we have to do a lot of things manually, we will not do that, and because we do not have time. Another challenge is what happens when you have the updates, and here is the process map. So you see from the, let's say, data integration, clash detection, data verification, data enrichment. You can use also BSDD, quantity takeoffs, then selection sets or class classifications, and then intelligent planning and scheduling and progress monitoring. In all this, you use mostly IFC or BCF, but with this automation, what we achieve is whenever you change something in a BIM model, it's automatically update up to 80% of your schedule or cost estimate. I don't want to say 100 because there is always something missing in IFC. But with this automation, you can have a just-in-time information. As you know, in construction phase, the value, if I have information today, the value is 100. If I have in a week, it's 30. If I have in a month, it's usually, unfortunately, 0. It's just post-fact analysis because it's too late to change something. So this is why automation is important. And another thing is to generate a lot of data automatically, because if we cannot degenerate, if I see how I can create manually 10,000 tasks, that's brilliant. But the key question is, will I do that? And what happens if the design is changed? Can I update this just in time? And that's what we try to answer all the time. So now I will explain to you just some of the processes. So in this particular project, we will have around 130,000 elements, so not too big. But we are using 61 different templates, such as clash matrix, information delivery specification, rules of measurement, scheduling methodology template, and all other templates which are very useful, BSD templates, which are very useful for analytics. So what are the basic facts? You have, in this case, 19 IFC files. This is just the project where this was demonstrated. Unfortunately, we cannot share real projects, especially when cost and estimation and earned value analysis are there. Of course, you know that data is quite sensitive, but essentially you can see this is just a basic model. Then just move further. This is how some visualization results can be seen in the cloud or in the desktop version. Everything is, basis of everything is, of course, IFC, so properties are there, relationships, and so on. And then this is the all templates we have. So in this case, you can use in BEXEL various templates. So literally all data sources are acceptable. So let's, any API could be used. But in this example, we usually want to say Excel is an excellent open format for data templates. So you can use JSON also, it will be shown here, it could be XML. But when you mention to us maybe XML or JSON, most of the people will say, okay, I understand what you are talking about. But when you say it's very simple, just develop IDS in XML, we say, okay, what XML is. And in Excel, it's very easy to change and customize everything. So that's why, and we hope that Excel can be also used because it's open format by the others as well. So in this case, we use selection sets, custom breakdown structures, data validation, data enrichment templates, clash matrix templates, cost classification templates, rules of measurement templates, and schedule methodology templates. So these are the templates, 61 in total have been used. So this is the basic one, data verification workflow. So just load a model, load any JSON, Excel, NatSpec, Kobe, any other type. It was interesting. BIM-Q from Thomas, for example, you can with third party easily integrate any other data check system, run automation, create automatically selection sets of the elements where the data is missing, and then produce the data in BCF, in BEXEL Viewer, dashboards, in our portfolio manager, send in IFC, in BCF, in JSON, in any other open format, in Excel at the end, because we always believe that open data must be used at the end so everybody could access and read this data. So this is, it will be shown at the end, a short video how actually this works, but basically you load a certain template, you want to check all the properties, just load in this Excel or JSON format. This is a standard developed a couple of years ago by buildingSMART, and the system automatically generate all the results, what is missing, what's not. It's by different colors, so you cannot see unfortunately here, but it says, okay, for that type of the group of the elements, that property missing in 1000 elements. So you can just drag and drop this to BCF and send to all stakeholders. So very easy, very open. We believe that this dashboards reporting must be also just in time, because if I need to produce report in a month, again, it's too late. So it's need to be accessed immediately, and that's what we achieved. So literally all these reports are directly generated. Then these are statistics, data verification, dashboard, just on a single button created. So it could be in Excel, could be in Power BI, you isolate each element. It will be shown in the video how it looks like. So next thing is data enrichment. So BEXEL has an interesting functionality. So based on a certain rule, so for example, if the element is column, if it's a bearing column, if it's concrete, it's going to be, let's say, B2010 110 code in uniformat, or in DIN 276. So you can define the rules and use any property you have in the system and enrich data automatically. And you can use Excel for that. And what is good news, a lot of companies or clients around the world develop their own Excel templates. What is also I forgot to mention, it's API. So everybody could wrote its own full system which use XML. It's fully open, accessible, so everybody. We have in more than 60 countries different templates for this. What can we also use this BSDD, and it will be shown here. And again, all analytics go in all deliverables which are necessary. So this is the way how system actually add uniformat codes, or let's say unique class codes and so on. So just basically by loading those templates. So the idea is not to make additional burden to the contractors or to the designers, but to automatically add hundreds of properties. The next use case is that BEXEL uses specific data enrichment for Eurocodes that automatically add Eurocode based on the IFC properties. And then BEXEL use BSDD not just to add properties on a single element or group of elements, but to the entire project, because he reads that BSDD code from BSDD's server schema and automatically add for a pump 20 properties, for a valve 15, for a wall 10, and so on. So the idea is always what we do is what happens when we update the model. If we need to do that manually, it's good, but we are not going to do that because we are very busy with other stuff. We cannot just focus on BIM, and unfortunately, in construction phase, a lot of projects fail because of that. So this is about BSDD. Then clash detection, don't want to take too much of your time, but load, smart selection sets, rules of measurements, combine them, run all clashes. You can have maybe comparing to, let's say, some other tools you have beside clearance, duplicates, hard, you have a containment. So identify which elements belong to the certain space and automatically add IFC relationship respective, so contained in or so on. So this is the only difference. Again, everything with BCF, dashboards, analytics, reports, so works. So you can see visually clashes, clash matrix below, and this is on the cloud. And you will see also how this integrated reports look at the end with the other statistics and so on. Maybe just to mention that all this, and now we have a tool which called Portfolio Manager, again, cloud-based, which can combine all analytics on all your 300 projects. And you can see combined total number of hard clashes at the moment in the Netherlands, for example. So this is also the idea, and the data is coming from BIM model, not the opposite. I'm just entering, okay, risk is high. To be honest, I don't like when you put just risk is high, because I as a human decide what is high, what's not. So these are various dashboards and reports. The next unique feature, it's heavily used by our clients, luckily for us. So it's a BIM-based cost database. So in BEXEL, you can load any industry standardized database available, but you can also generate automatically the cost structure according to any template like BIM 276, Uniclass, Master, Uniformat, and others, based on the properties you have in IFC. So again, use as much as you can IFC. And then automatically, this is with formulas, rules of measurement, which are defined. The system can automatically, in a very professional manner, create a cost estimate. And whenever just to give you an idea, if I have 10 types of doors, in the exactly specified uniformat category, they're going to be automatically generated 10 cost items. And the rule of measurement could be count or area. But when I add the 2 new types of doors, the system will automatically add those doors because he have analyzed IFC and generated this. So just to move further. So this is now how cost is generated with all unit prices, baseline cost, additional margins, and so on. And this is how it works in IFC. So it's fully supported IFC schema. By the way, I will have a presentation together with Vice President of largest Midwest company, Clayco, a design build company today, and we will talk about specifics and what we could improve in IFC in construction stage. But this is more or less just IFC. And then cost classifications, again, how in a very smart way. So now I would like to speed up. debate, but there are a lot of videos, everything is available and so on. So again, BEXEL reads all the data and automatically by methodology, which is unique BEXEL feature, we are using this for 15 years, generates the schedule. So how? Because it knows that foundation or excavation must be done before facade. So by now, and this information comes from IFC. And then by just loading BEXEL schedule logic templates, system automatically generates literally in a second schedule, which is a huge time saving. And it's always, Tomislav, actually vice president of Playco, will talk about this and what they identified on a Microsoft data centers projects if the data is coming just from Primavera. Then you can see simulations and so on, and Gantt charts, but also what is important, line of balance. So location-based scheduling is in BEXEL natively supported, and this is very important for construction planning. And then progress input, you send a look-ahead plan for each subcontractor or any group, visually those elements to the site, and then on the viewer, BEXEL viewer, or in any other application which supports BCF, can just select, fine-tune what was actually done, send back, and see all earned value analysis. You will see the results, so you can see a planned, actual, cash flow, analytics, and so on. So now it's time to show you the video. And everything which is set here will be shortly presented. And then I just need a couple of seconds to mention some of the clients who actually have been involved in this. So this is the process map. And now we start with basic, let's say, loading IFC files. BEXEL supports some other formats, but we like IFC most. So this is IFC is loaded, around 100, I don't know how many IFC files. No, it's 19, but around 130,000. So this is a data enrichment. So now automatically BEXEL added 3 new properties for uniform data based on just small template defined here. We can always visually see all those elements. So have a check. So with the color coding, if something is missing, we will not see those elements there. The next use case is how we can combine BSDD. So we are now adding the Euro codes. Again, in Excel, everything is very easy to be understood. So it's not complex, it's not closed ecosystem and so on. And now we added Euro code automatically, and it's small add-in, load properties. So this add-in was developed in 1 day. So just to have an idea how simple it is. You choose one type of classification, click OK, and now you will see the system automatically added around 20 or 30 properties based on the Euro code, and the data is coming from BSDD. So whenever we update BSDD, the data will be automatically updated. And we can visually, of course, see where are beams, where are proxies. So these are, let's say, ducts. So we can see if all properties are there. If everything is recognized properly, we always can visually check if the elements, of course, we can later change the properties, but we also suggest that it is done automatically, but it was shown as just as the case. So next is a very simple way for clash detection. So you load the sample of smart selection sets. So these are rule-based selection sets, you know that, so IFC-based. So it creates around 30 smart selection sets. We visually see what is included in walls, what are ducts, so we can check if this is okay, and then load the clash matrix template from Excel. Very easy. Which group of element against which does, is it clearance, is it hard clash? Just load, you will see now, load those 37 clash jobs, click update all, and in a couple of seconds, you have all clashes, of course. So nothing special with this, but again, implementation of fully open IFC. And now you can group those clashes, similar like in some other tools, but and can drag and drop, which is very important, of course, all these clashes to BCF Manager and send to any other platform just to use this for collaboration. And this is a dashboard, one which does not include viewer. You can go on our websites here and you will see now some examples, which includes also BEXEL viewer with the dashboard. So now the quantity takeoffs Very simple way. You load the template, for example, for uniform quantity takeoff, click OK, and now you have all quantities generated here. And the system now, unfortunately, we do not have time. It was elaborated in our submission. BEXEL automatically, based on the rules of measurement for certain company, certain country, and so on, generates, and the property data generate one or more cost items for each element. So, for example, if we have a bearing wall, it could be formwork operation, which is used twice area formula. If reinforcement, kilos, weight. If concrete, cubic meters. And then when we have this, we can load the prices if we have them, or we can even read the prices from properties if we have, and we automatically create the cost estimate. And this is, if you want, you can see in live how this is generated. And then we use this methodology. Although it looks complex, it's developed in 1 day. And you can reuse this methodology on all similar types of the projects. Just to give you an idea, residential building versus football stadium and hospital. 85% of all items is the same. This is a line of balance. So optimal schedule, it's called in Germany Taktplanung. So you see all those lines are organized in a perfect way in order to have optimal delivery, like an assembly line. And then you can see a cash flow, labor usage, visual simulation, we call this Hollywood BIM, but it's nice, but most important is where the data comes from IFC. So you can see how it looks like, and I will finish in a minute. So just you see how this is published. Maybe just to mention here, this is how it looks in Viewer. BEXEL can organize IFC files according to any way you have in the system. And this is just, for example, earned value analysis when the progress is entered. So you will see just publish this integrated Power BI and BEXEL Viewer, and you can see a cash flow, schedule variance, cost variance, everything fully integrated. So you can isolate 1 month what is done. You can choose the color coding. All the data is coming from BEXEL system and BEXEL CDE. So you can see what's happening in the project and instantly have results. So to do that manually, usually it takes a month or 2 months, and it's already too late. So this is a resource analysis. For example, we see where carpenters are working, are they productive? What about, I don't know, dozers, are they performing well or not? So just for contractors' ability to get the most of the BIM. Unfortunately, as you know, we still, even today, we do not have too much contractors. We need to have them as well in openBIM. And this is planned versus actual, how you combine two BEXEL viewers. So you see each month what was planned and actual. Of course, you can see with different colors, situation, what is different and so on. And just the last slide, I think Sean was a bit more time. I think I tried to be 20 minutes. But anyway, just to mention what some of the clients who helped us in this submission. So one is Clayco. So Vice President and Chief Technology Officer of Clayco will join me today at 1:30 in construction room. So we will talk an hour and a half, so slightly more than this time, about how this is implemented and also their strategic vision. Also, Larsen & Toubro, largest Indian, but also maybe largest Asian contractor in a construction company. Nesma, largest or second largest Saudi Arabia company, and two companies from Europe, Archipro, largest design build company in Serbia, and ATI Project, one of the largest designers in Milano. So they helped with those templates which are developed here. So thank you for your attention.
Thank you, Velko. Thank you very much. We'll come to questions at the end. So now I would like to invite Rick Klooster up from Future Insight.
Okay, great. We executed the first proof of concept in 2019.
project was executed last year. And since it was, there were more people involved, and it's not BIM people who already know what we're talking about. It's the guy from the fire department, and it's the sustainability manager, and so 80% of the people have no idea what BIM is. Typically, it sounds pretty complicated. So we spend a lot of time figuring out what's necessary over there. And the idea is that we're going to upload the BIM. So we had to implement a system within their registry. So it's not a separate solution. It should be really simple, and it should be fully integrated within their system. One of the other things we're doing is that within the building, in the permit process, there's all kind of forms which you have to fill in, the square meters of the building, the height, the function. And we also auto-populate a lot of these forms now with information from the BIM file, so people don't have to do it manually anymore, which of course saves a lot of time. The whole system isn't obliged, you don't have to use it, but the idea is that it will be faster, it will be easier, it will be more transparent. So what we see within Estonia is that the developers and the architects are really eager to start using it, because their process will be faster. They can start using it themselves and check themselves if their design fits the requirements, and they can do it how often as they want. This is what I already told. So this is an image from the proof of concept for 2 years ago. We already also did a file for the awards. We got a special mention, we didn't win. And here you can see some first 10 checks, which are kind of virtual, not real checks. And now we did the real thing. Let me see if I can start the video. So here we have a short video explaining what we've been doing. We made this at the end of the project to explain it to anyone. Yeah, so you can imagine this. There are developers, contractors, whoever, who is already making their design in BIM. During proof of concept, we did a survey in Estonia, and it's really a high level of BIM support. They're using it, so that's not a big issue. What we've added now is within their national building registry, the IFC, the possibility to upload the IFC. So we've added the IFC database there. We're also using BIMworks. I just saw Scan and BIM mentioning it as well, and making that scalable. And then based on that, we've added the servers to automatically execute the checks, but also auto-populate the forms. One of the things we're also discussing now is, for example, to use it to build your 3D cadastre or something, because that's also something you could easily do from here. So here you see it's the building permit application. It looks like this. And once it's relevant, so you don't always see it, but once it's relevant within the process, the application will pop up and you can see the design. So you can see it's, you also see the environment, which we didn't put in there. That's just the national digital twin they have. And we connect it using 3D tiles. So we support 3D tiles, and that way we can easily show every design in the environment, which is already, of course, a really important first step to evaluate what's going on. We can switch between layers, 2D, 3D, whatever. And that's not something we built, yeah, we do it as well. But if it's there, we can use it. Some really simple controls to turn off floors, to do some measurements. But again, as simple as possible. These people are used to Outlook and Word. So it should be really simple. And then over here, you see the checks. So there's a lot of, there's 8 regulations which are put in there. So here is a check looking for the good direction of the doors. Are they opening in the good direction depending on the escape route? And you can easily see what's good or what is not good. Another one, you should have an entrance to the dwelling. So over here now we've added the article, and then you can see what it should be and what it is. And then in one view you can see which one are good or not. This is for the disabilities. And the ramp can be 10% or something, easy to check. And now everything is still at the same place. In the future, different people will see different results. Here there was a check if you could fall off the stairs, and here's a number, the escape routes should be a certain length, and you can see we've used a graph to really calculate how long the escape route is. In this case, it was a false negative because over here is a fire door, but it wasn't. It didn't have the right properties, so that's why the checks were going wrong. So then you go into the BIM requirements again, because you may have to make sure that those stuff is in there in the proper way. In the end, you can download the results as BCF, use it in your authoring tool, update the design, and then try it again. Let me go back. Yeah, okay, great. So we've made about 60 checks currently. So they made a list of, I think, 100 checks from different regulations, which they picked all kind of articles. And we went through them together with a small group to discuss, okay, is it possible, is it feasible to translate them into automated checks? There were some things which were really detailed, really complicated, and will never work. So we looked at the usability, how much work would it save? Does it really help? And at the same time, is it feasible to check? Because if we need to make a lot of extra requirements, it will probably never work. So that's how we kind of got to the 60 checks from different legislation, so fire safety, building design, disabilities, and this is the first. And we figure also from the 60 checks, once we really implement it, 20 or so won't really be useful. You have to really start using it with the cities as well. The idea is that first we start with the city of Tallinn, and then it's rolled out over the entire country. But of course, you need BIM requirements, and I'll show them later. So this is how it kind of works. I've showed it yesterday in the presentation as well. And so we've integrated the database, which makes it much easier, faster. We can index the BIM designs, so we can also query for certain objects. And we combine it with the digital twin, and then on top of that we can build or service different applications. So we're not just using the buildingSMART, we're using the buildingSMART standards, of course, but we're also using a lot of OpenGIS standards and just general web standards. And especially by combining those two things, you can really easily integrate stuff. And what we see is that a lot of these checks are also relying on spatial information, because it depends on where a building is, how high it can be, or what kind of so a lot of variables which you need to know before you can start executing the check. You need to get it from somewhere else. And one of the parts of the project was also to set up a national BIM requirement, so not per contractor, but something like, okay, this is what we need as a government to provide. This wasn't a lot of this was already there, so we've used it, and then we've also checked what do we need from the checks. And I think 90% of this stuff we didn't need; it was just already there. And then I think we had 15 requirements which were really necessary, and half of them weren't in there. So we added some extra properties and stuff which need to be defined properly. One of them being really simple, the living room and the kitchen and all the spaces should be named properly, but there wasn't a study, for example, in this list of possible rooms. And just a short overview. So this is a nice check. The article was when you're living on the 4th floor or higher, you should be able to get to the access through an elevator. So then we need to detect the apartments, we need to detect the elevator, and we need to calculate if you can get from the room through a public area to the elevator and that can then get to the exit. So we are not using just rule-based checks, we're also using more complex algorithm checks, and we combine them. Okay, here's another nice one. The handrails. There were, I think, six articles about defining how the handrails exactly should be, which is almost impossible to check. You can do it, but then everybody has to do it properly as well. So we replaced it with a voxel check, where we just walk over the stairs and see if we can fall off a certain thing, which has much less requirements, and that way it's more reliable. And here this is the proper evacuation route with the good fire doors. You can see now it's green. And we connect to a national system where it says, well, depending on the function and the amount of people working in the building, the variables are set. So we read that out first, and then we execute the check. Here the image I said how it should work. So there's the applicant and the permit issuer, and then there's a system. So the idea is that the applicant will get access to the system. It's a service online. He can start the checks himself. So he uploads the file, and automatically all the checks are run. Then he can see the result, but you can't really read it. Here we have some really building checks, which you just need the IFC for, but you also have a lot of area checks. So you need this combination with the digital twin. Then you get the result. You can fix it, try it again until you think, okay, now it's good enough. And then you can really file for the permit when we see that you can. There's an automated process, and it's also just a manual process, but you can use it within the system. And remember, it's the first introduction for a lot of people, so it should be really simple. That's why it's easy to use online, and we really try to make the buttons specific for the users. What we see is that the stakeholders really like this way of work because it's much more transparent, faster for them. They know what's going on. We still need a lot of additional geo information because the zoning plans weren't there, at least not good enough to use in the checks. It's often not possible, at least not in one turn, to translate the regulations into a fully automated check. So it can help, but there is still work to do also there. In Estonia, it's being kind of an agile process with the technology, with the users, and with the people setting up the regulations. It will be available early next year, I guess. And using the open standards, especially on this level, it's key. You need it. You cannot use just one system. Okay, 1, 2, 3. Oh, okay, almost there. So we've built this for Estonia with Estonia now. And this is maybe a nice addition. So we're part of the Horizon Accord project, which is about making some kind of a standard framework for BIM-based permit checking. As you can see on a cloud-based permitting service, there should be a compliance checking service using APIs and the open standards, data dictionary, BSDD, information requirements, IDS. So implementing all the standards in here. And here is an important one. To specify some kind of a standard way to make rule sets, because everyone's doing it differently now. It's with Estonia, Finland, Germany. So from Finland, Sotheby is also in there. And it would be great, of course, if in extension to the IDS and stuff, if there's some kind of a standard way, because everybody's life will be much easier. Project will run the next 3 years. We just started. So we see that there's more and more people looking into this, and I've seen a lot of tools with much more possibilities yesterday and today. I think what we're really doing is implementing it and making it usable for the other users who don't want all the buttons, just the buttons they need. So that's it. Thank you. Not just me, I want to mention Jan. He is from the ministry in Estonia. What's really great over this, it's a small country, but they really dare to innovate. So they just started. We didn't design the whole thing in front and it should be perfect. We just start, make a first version and then improve it, involve stakeholders, and seeing is believing. And that's what we see over there. It's really starting to work. More people are getting involved. We get more support. And one of the things is that we're having a close collaboration now with Finland, talking about implementing it there as well. And especially since it's all open standard, it is scalable. You can use it anywhere. You have to change the IDS, you have to change the requirements, but in the end, all the building blocks should be the same. And that's really cool. I'm here the next 2 days. Jan is there as well, so if you have any questions, don't hesitate to contact us. Thank you.
Thank you very much. Okay, so now we'll have some time for the jury to ask any questions. If the presenters would like to come up, I will just get Dr. Sean back online here.
Quick, so you know that.
Yes, yeah.
We will now agree how to integrate our systems. We
Yeah.
actually talked yesterday.
Okay. So any questions from the jury? I'll just move the microphone forward a bit.
I have a question for Sean.
Yeah.
Sean, can you hear me? This is Matthijs. Did you say you have the viewpoint fixed or almost? Like when first you had only the AutoCorr logo as the viewpoint image, but did you say that you have created a way to really use the viewpoint?
To use the viewpoint in the BCF, is that the question?
Yeah.
I'm having trouble hearing. Yes, when you click on the issues, it automatically takes you to the component with the information about the deviation analysis and how to fix the component within the authoring tool or the design review application. And all the versions of BCF are supported, and of course the camera view works in all of those versions. Was that the question?
Yeah.
Any other questions from
Sorry about that. Yeah, BEXEL. Let's call it BEXEL. So thank you very much for the presentation. You talked a lot about data validation, but do you actually check the data quality by itself, or do you validate means only to check it via data catalog or template, etc. So is it including the data quality as well? What happens if you see or if you come across a faulty file or whatever?
You mean check the quality of IFC itself?
Well, you get an IFC and
Yes.
and you validate. You said you validate the IFC.
Yeah, we validate the values of the properties in IFC. That's it.
Okay.
So you can check their various types. I'll just give you ideas. For example, family names, you can define regular expression if it fits. Names of the IFC files, you can. Or let's say the value of concrete strength must be between 30 and 50. So you can check the range. Could also have conditional checks. So if it's concrete of certain type, must be also added 3 or check 3 new properties. So check type, and also could check the value lists. So if you so this is more or less.
Okay.
So IDS at the moment, let's say what is the scope of what Leon and the others become. So this is the natural, maybe slightly extended.
The
But,
Leon catalog.
Hmm?
The Leon catalog.
it's not okay.
You said all data sources are acceptable. What do you mean by that?
Who said me?
Yeah.
When you say
All
data sources,
data sources are acceptable.
they are in which stage? Just you mean in which when I mentioned.
Where in the presentation?
Yeah, but just can you tell me which part you mean? In which to deliver the data or to read the data? So just
I think it was read.
okay. Primarily we have IFC. We are IFC certified for long time with buildingSMART, so we can read, of course, IFC, all formats. So now we are extending to IFC 4.3. We have with some tools direct ability to have, like with Revit or some other tools, direct integration or Navis and so on. But we hope in the future the focus will be on IFC integration, because with IFC, most of those large projects, you literally have 5, 6, 10 sometimes auto reports. One for the road, another one for structural design, third one for architecture. Usually all those big complexes have various auto reports, so having dependency on a single auto report is a bit tricky. And the next issue is with the data charts again, because then you will need to combine one for Tekla, another one for ArchiCAD, one for Revit, because all they have a bit different properties. So that's why it would be better. So usually when we are managing the projects or let's say supervising the execution, we usually set up the rules like that. But if I may add, what is more important, openness to the export data. So the ability to export data. So for example, in BEXEL, one interesting feature is when you select, create a list of literally any type of selection sets and groups, the system automatically creates specific IFC files, where the entire model with 100 IFC files is divided up in a different way based on your desire. So BEXEL can read IFC, but also generate IFC as a deliverable format, and we use that IFC in our CD.
But how do you make sure that it's still the same file, the same geometry object or whatever? So if you export, maybe the designer is responsible, right?
Yes.
When someone else enriches and exports, how do you make sure that it's still the same intended design?
You literally attach all the properties you read from original auto input in IFC, let's say, are exported in the same quality. So it's the same quality. The only thing which could be, so we do not, in our ecosystem, in our CD, we can just change the position of the element, because we do not create geometry. We do not have semantics behind. So we can just change the location of a certain door in the model. But the geometry description in IFC related to the element will be one-to-one the same. The only thing what we can do is add new properties or change existing ones. But it's controllable process, so it's clearly defined who can do that. But it's very important to clear that. So who is responsible? So our domain is construction management domain. We are not the authoring, and the authoring pool should be responsible for high quality geometry, because they have entire semantics and know how geometry is done.
Great. Any further questions? Perhaps for
Question for this? Question for Rick? In the Netherlands, you have like a 6 weeks period where the public can look at the design, right? And maybe provide them. Is that also in Estonia? And how is this done?
It is the case in Estonia. We haven't really implemented it yet, but the idea is that once that period starts, it's a trigger, someone presses a button, now it's okay, then the model will be automatically put into the digital twin, which is also available, and then people can just check it over there and leave remarks. So it is pilot is implemented yet, but the technology is up and running. So it's just,
Why is it not a project in the Netherlands?
I don't know. I think what I said is that that's really cool. Estonia, they are digital from when they started, so I think they are taking a bit more risk. But also the government is smaller, so Jan is pretty directly below the minister, and he can make decisions. He has the money, but he also knows what he's talking about. I think if the country is larger and there's more different departments and the top 5 layers of civil servants have no idea what this is about. So then I see now that I'm getting some some momentum in the Netherlands as well, because you can show it, and seeing is believing. But then it's, oh, this is cool, we want to have it. But if you start explaining it with 5 standards and then all kind of pictures, and now you have to figure it. Things like it's all together will be great. But make it happen. Sounds complicated. Let's not do it.
If I may add, what I really like what they are doing, and we try, when you achieve something, you just show to the others. Do not push them. Whenever you are ready, most welcome to join. But that's what is happening, and that will happen with what they are doing, because this is really, to be honest, we are interested to integrate this in our country as well. And also with our clients, 5-10 years ago, you need to call, please try to believe us, and so on. But now, fortunately, you just show the best use cases. The only very important thing is to focus on the benefits. If you are just doing BIM for the sake of BIM, then everybody will use that only if it's mandatory. But if you focus on the benefits and the time saving or identifying mistakes and so on, but you have a very good metrics, how you measure the benefits, that's the easiest way how you convince everyone. Then you don't need the regulations.
What we do see now is that because it's all open standard, so and international, so you could copy it everywhere, and it's kind of working. So that the risk to adopt it is getting smaller now. But you can just use it, put in our requirements, put in our. You can copy checks, change them to our local situation. So we see that it's getting adopted, and it's really exciting, of course. So it's not just our system; it's a combination of the different standards working together.
If I just want to add one good point, what he said also, add-ins and openness to APIs is very, REST APIs and classical APIs is very important. So what he is referring to is that some country the system it will be added. And we have experience of, for example, NESFA in Saudi Arabia developed beautiful methodologies and checklists by themselves. So this is the idea, not to manage them, but to allow them to tailor everything according to their needs. And that's the, of course, key for success for this community.
Okay, we have 5 more minutes if there are any more questions from the jury.
All clear.
Great. Well, thank you very much to all our presenters today. Thank you everyone for attending. We hope to see you at more of the sessions at the summit throughout the week. If I could ask everyone to please leave the room except for the jury to stay behind for deliberations. Thank you, Sean.